Electricity powers our world, from washing machines to the annoying alarm clock that always wakes us up. But how do we go from some water turning a wheel into powering up a light bulb? In this video, we'll go over what electricity is, how it is generated, how it provides power, and the difference between AC and DC. Let's go over electricity first. Everything is made of atoms, which are made of protons with positive charge, neutrons with no charge, and electrons with negative charge. In an electric wire, commonly made of copper atoms, the electrons aren't exactly bounded to each copper atom. Copper atoms are linked to each other through a metallic bond, meaning that there is a sea of electrons in those wires which can easily move around. The electrons can be moved by external forces, and this movement of the free electrons is what electricity is. So now, how is electricity, or the movement of electrons, generated? It is based on Faraday's law of electromagnetic induction, where if you move a magnet through a coil of wire, or rotate a coil of wire around a magnet, an electric current will be generated in the wire. So, in the case of generators, they use other forms of energy, such as wind turbines, steam, or water wheels, to turn wire coils around magnets, generating tremendous amounts of energy. So in other words, generators turn mechanical energy into electrical energy. Using Faraday's discoveries, we can also explain how electricity powers stuff. When moving through a wire, electrons produce some heat as they rub against it, and the electrons also generate a magnetic field. So, to power a light bulb, the heat from the electrons make the filament glow, giving off light. To power a washing machine, the electric current gets converted back into mechanical energy, like a reverse generator, to power the motors of a washing machine to make it spin. And to power a computer, the magnetic field generated can be used to change computer bits, giving us calculations to make it function. This is why electricity is probably humankind's greatest discovery. It is very versatile in what it can do. And before we go, let's touch on AC and DC a bit. Aside from being a great band name, alternating current and direct current describes how electricity travels. AC travels in alternating directions in a wire, while DC travels in the same direction. AC is generated from an aforementioned generator with a spinning wire coil, and it is best used over long distances, say from a city generator to our power outlet. Meanwhile, DC is generated from a battery, and it is best used if a steady stream of electricity is needed, say for a flashlight. We use both most of the time. Say, if we want to power our computer again, we first need the AC from the power outlet provided by a generator to DC used in the batteries of a computer. In this case, a block called the power supply acts as a converter between AC and DC. And there we have it. Electricity is just a flow of electrons that moves freely inside a metal wire. By using mechanical energy to rotate a wire coil around a magnet, an electric current is generated inside the wire, which in turn powers electronics all over the world by generating heat and magnetic field. With the combination of AC and DC, the electron travels in different directions to fulfill different roles. I hope that y'all have learned something interesting today. Thank you for watching, and stay hydrated.